Good morning, everyone. We are looking at Chapter 3, Derivatives, Section 3.5, the chain rule. Here's the second part, implicit differentiation. Implicit differentiation. We've covered everything from derivatives and rates of change to derivative as a function, basic differentiation, formulas, the product and quotient rules, and now the chain rule is the second part. As you can see on this page, we have all types of formulas that we have dealt with from the definition. F prime of x is the limit of f of x plus h minus f of x over h as h approaches 0. Different formulas for differentiation. The product rule, the quotient rule, the chain rule, exponential rules. Those are the differentiation formulas. And now implicit differentiation. Functions expressed by one variable are defined explicitly in terms of another variable. Examples would be y equals x squared minus 2x plus 1, or in general, y equals f of x. Some functions are defined implicitly by a relation between x and y such that x squared plus y squared equals 25, or x cubed plus y cubed equals 6xy. In some cases, it is possible to solve such an equation for y, and in some cases, it is not easy or even impossible to do so. In such cases, we can use the method of implicit differentiation. This consists of differentiating both sides of the equation with respect to x, and then solving the resulting equation for y prime or dy dx. Let's start with a simple example. Here's the warm-up example. We want to differentiate 4x plus 2y equals 10. Explicitly means we can simply solve for y. To do so, we are going to move the 4x to the right. We are going to divide everything by 2. Y becomes negative 2x plus 5, and clearly y prime is negative 2. We are going to look at the same question implicitly, which means we are going to differentiate just the way it's given, term by term. And I'm reminding you that if you want to take the derivative of a function g of x, the answer is g prime of x. Therefore, the derivative of y is either y prime or dy dx. So this one is 4, this one is 2. Remember, y is like g of x, so 2 times g prime of x, or 2 times y prime, or 2 times dy dx. Any number will result in 0, and we are done with calculus. We move the 4, we divide by 2, and on purpose over here I called it y prime, I called it dy dx here, just to remind you they mean absolutely the same thing, everybody. The two are the same. Okay, there is no difference between the two. It's just different notation. Given the circle, here's example 1, x squared plus y squared equals 25. Find y prime, so we are going to differentiate both sides implicitly. So x squared gives you 2x, but what about y squared? I want to remind you of the extended power rule. D dx of g of x to the power of n is n g of x to the power of n minus 1 times g prime of x. Therefore, the derivative of y to the power of n follows the same format. Instead of g of x, you have y. N, instead of g of x, you have y to the power of n minus 1. Instead of g prime of x, you're going to write y prime or dy dx. Therefore, this is 2x, this is 2y y prime. Any number will result in 0. 2x plus 2y y prime, any number will result in 0. We will move the 2x becomes negative on the right side. We want to solve for y prime. We're going to divide both sides by 2y, and the result is minus x over y. Y prime or dy dx is minus x over y. Now we want to find the equation of a tangent line to the same circle at this point. So we have a point, we need to find the slope. So here's the pair, which means x is 3 and y is 4. Plug it in here to find the slope. And so y prime is minus x over y. Plug in, you get negative 3/4. Y minus y1 equals m times x minus x of 1. So y minus 4 equals m negative 3/4 x minus x of 1, which is 3. We are going to distribute negative 3/4, which results in negative 3/4 x plus 9 over 4. We are moving the negative 4. We make it plus 4. As you know, 4 is 16 over 4 with 9, 25 over 4. So y is negative 3/4 x plus 25 over 4. And if you plug in 3 here, you get negative 9 and 25, 16 over 4, which is 4. So it shows that we didn't make a mistake here. It doesn't say anything about this slope. Find dy dx or y prime, x cubed plus y cubed equals 6xy. This is the equation, this is the relation, and this is an example that it's not easy to solve for y. So first and foremost, I'm going to put a raised dot between 6x and y. So this times this requires the product. So let's do it one by one. X cubed with the 3x squared. Y cubed, 3y squared dy dx or y prime. 6x, 6 times y. This is f prime g. Plus y gives you y prime, or since we use dy dx times 6x. So what we are looking at in essence, we have f times g, we have f prime g plus g prime f. And so we want to solve for dy dx. We are going to move things around as follows. This moves to the right. Because this one has dy dx, we're going to move to the left, meaning anything involving dy dx comes together on the same side. Now, we are going to factor the dy dx. Also, there's a factor of 3. On the left side, we get 3 times y squared minus 2x times dy dx. And on the right side, we can factor the 3 out. We get 2y minus x squared. We divide both sides by 3 times y squared minus 2x. And as you can see, this cancels out. 3 and 3 cancels out. And dy dx becomes 2y minus x squared over y squared minus 2x. Find dy dx or y prime. I'm going to put a raised dot here, meaning I need the product rule for this, for x squared times y. So I get 8x times y. So that's f prime g. Now I need g prime f. The derivative of y is y prime or dy dx times 4y prime times 4x squared. So right here, f g, let's write at top of it. So this is f g, this is f prime g, this is g prime. And then 2y squared, we follow that. 2 times 2, 4. Y prime or dy dx, any number will result in 0. You don't have to move things around, class. Now, we are going to combine these two because they involve y prime, and we move the 8xy to the right, we make it negative 8xy. So this moves, becomes negative 8xy. These two, we can factor the 4y prime out, which results in x squared plus y. We're going to divide both sides by 4 times x squared plus y. So the right side divided by that, the left side becomes simply y prime. These two cancel each other, we get negative 2. So the answer is negative 2xy over x squared plus y as the final answer. We want to differentiate 4x squared. The answer is 8x. We want to differentiate 6y. We get 6y prime. We want to differentiate y squared. We get 2y prime. E, just like 18, is a number. The answer is 0. So this is a number, everybody. Clearly, these two can combine because we have a y prime that we want to take out, and we are going to move 8x to the right, becomes negative 8x. These two, not only y prime is in common, also 2 is in common. If I take the 2y prime out, I get 3 plus y. 8x moves. Let's divide both sides because we want to solve for y prime. Let's divide it by everything except y prime. So what happens? This one cancels out the 2, gives us minus 4. The left side is just y prime or dy dx. The right side is minus 4x over 3 plus y. In any order, of course, y plus 3, 3 plus y. All right, class, x times e to the power of y We are using the product rule on that. The product of x and e to the power of y. So x gives you 1 times e to the power of y plus e to the power of y, just like e to the power of g of x is itself times g prime of x. So e to the power of y plus e to the power of y times y prime. And then by the product rule times x, so we are using this one. Meaning if this is f, this is g, you're dealing with f prime g plus g prime f, 2y cubed 2 times 3, 6, y squared y prime, 3x is 3. We are done with calculus. We are going to finish the job algebraically. So we are going to combine these two to factor the y prime out. We're going to move this to the right and it becomes negative. So we get y prime times x e to the power of y plus 6y squared equals 3 minus e to the power of y. All we have to do, divide both sides by the parentheses, and that's y prime equals 3 minus e to the power of y over x e to the power of y plus 6y squared. Find an equation of a tangent line to x squared y squared equals 1 at negative 1 comma 1. To come up with the equation of a line, we need a pair which is given. We also need the slope, which is not given. So we are going to differentiate again using the product rule, x squared times y squared. So x squared gives us 2x times y squared plus y squared gives us 2y prime times x squared. 1 is a number, gives you 0. You don't have to move things around, just do them turn by turn. Again, if we were to call this f times g, we are looking at f prime g plus g prime f. We want to solve for y prime or dy dx. We're going to move 2xy squared to the right becomes negative. And we are going to divide everything by 2yx squared. When we do that, the left side has y prime only. And this fraction simplifies to minus y over x. So again, this is your only calculus step. Everything else we do is algebra. So what is the slope? Plug in the pair. M is minus y over x, and we put the pair here such that x is negative 1, y is 1. So negative 1 here, minus positive 1 here. So minus 1 over minus 1 gives you positive 1. Y minus y1 equals m times x minus x of 1. So y minus 1 equals m, which is 1x, minus minus 1, which makes it plus 1. So the right side is x plus 1. Add this, and we get y equals x plus 2. Implicit differentiation. Let's look at a different topic, related rates. If we are pumping air into a balloon, both the volume and the radius of the balloon are increasing. And the rates of increase are related to each other. But it is much easier to measure directly the rate of increase of the volume than the rate of increase of the radius. In a related rates problem, The idea is to compute the rate of change of one quantity in terms of the rate of change of another quantity, which may be more easily measured. So what's the procedure? Number one, find an equation that relates the two quantities. Number two, use the chain rule to differentiate both sides with respect to time, meaning the independent variable is t. So when we go with the Leibniz's notation, instead of saying dy dx, we're going to say dy dt. So it's dy du dt, the independent variable. Let's look at a warm-up example similar to what we just said, but with numbers. Air is being pumped into a spherical balloon so that its volume increases at a rate of 100 cubic centimeters per second. How fast is the radius of the balloon increasing when the diameter is 50 centimeters? By the way, they may just change this to changing the result. If it happened to be positive, it means increasing. If it's negative, it's decreasing. So you're dealing with a word problem. You have to read it a number of times and then see what's given. The rate of increase of the volume of air is given, which is how much? 100 cubic centimeters per second. What are we looking for? What is missing? The rate of increase of the radius when the diameter is 50 centimeters. So that means we need information from previous courses such as geometry, trigonometry, you name it. So a spherical shape has a volume of 4/3 pi r cubed. We should know that. And whether it's a sphere or a circle, the diameter is 2 times the radius. So that is a piece of information, prior knowledge of mathematics we should have. So the volume uses that formula. So what is given? The rate of increase of the volume symbolically is dv dt. So we are translating this into this beautiful language of mathematics. So this is dv dt equals 100 cubic centimeters per second. What is missing? dr dt. At what point? When these 50, which means r is half of that, 25 centimeters. So the volume is 4/3 pi r cubed. dv dt is 100 cubic centimeters per second. We are looking to find dr dt when r is half of 50 or 25 centimeters. So according to the Leibniz's notation, we are going to write dv dt, and the intermediate variable as we go from v to t, r is a function of t. So dv dr times dr dt. So when we look at this, 4/3 pi is a number. So dv dt is 4/3 pi. And then r cubed times 3r squared. And remember, we are taking the derivative with respect to t. So it's just like you have y cubed, then you say y prime. You mean dy dx or dy dt, in this case, r prime or dr dt more precisely. Now, when we put these two together, it gives us 4 pi r squared. We can plug in right here, or we can solve for dr dt by dividing both sides by 4 pi r squared. Replace the dv dt. This is where the given helps. You plug in, replace the r with 25. And as you know, 4 times 25 is 100. So we can say 100 is 4 times 25. Remember, we have two of them down here because it's 25 squared. So one of them goes away. you get 1 over 25 pi. Please understand, this is an exact answer, everybody. And pi is not 3.14, it is approximated by that. Pi is 3.14159, and it continues indefinitely because it's an irrational number. So please, in your writings, you always must have the exact answer. And now, it's just an approximation, you write. The radius of the balloon is increasing. Why increasing? Because this value is positive. At what rate? Precisely 1 over 25 pi, roughly 0.0127. The units are centimeters per second. And I want you to see why it works that way. First of all, dRdt, the change in radius over change in time, gives you that unit. Secondly, if you look at this formula, when you were doing that, this has the units of cubic centimeters per second. And this one are as the units of centimeters, and we are squaring it, and this becomes exactly that. In other words, whatever we do to numbers, we do to units, and they work.